Hello guys, welcome to All Clear Tube. So now we are going to see what is deterministic finite automation, shortly called as DFA. So in DFA, for each input symbol, one can determine the state to which the machine will move. So for instance, take two states, A and B. So on for each input symbol, okay, as for say for input symbol 1, it goes to B. On input symbol 0, let's take it as it goes to C. So next point is, as it has finite number of states, the machine is called deterministic finite machine or deterministic finite automation. So let's look at the formal definition of a DFA. So a DFA can be represented by a 5 tuple. So the first tuple is Q, second sigma, and delta, Q naught, and F. So Q is a finite set of states. So Q is the total number of states available, and sigma is the finite set of symbols called the alphabet. So this is the input symbol provided to the machine, and delta is the transition function, where delta is Q into sigma gives Q. So Q naught is the initial state from where any input is processed, and F is the set of final state, or it is the final state of the machine. So let us see a DFA with an example. So consider this example. Construct a DFA which accepts strings ending with 100. So the total number of states for this is Q is equal to minimum length of string plus 1. So Q is equal to 3 plus 1 equal to 4. So we got the total number of states for the DFA. So we can take the 4 states as Q0, Q1, Q2, and Q3. So Q0 is the initial state, and Q3 is the final state, so in this mathematical equation we got the Q as the states. So these are the total states, and sigma is the finite set of input symbols. So let us take it as 0 and 1, and this is the transition function which we'll construct it using the transition table, and Q naught is the initial state. So here we are also taking Q naught as the initial state, and F is the final state. So Q3 is the final state. So let us now construct a transition table. So we'll now see a shortcut method to construct the transition table. So here we'll give the total number of states for the DFA. So Q0, Q1, Q2, and Q3, and here comes the input symbols 0 and 1. Okay. Now you just write for the initial state Q0, you just write as sigma here, and 1, 1, 0, and 1, 0, 0. Since the final state should be 1, 0, 0, you should write it like this. Okay. Now first what you have to do is sigma 0. So sigma 0, check if there is a sigma 0 in any of the states here. So sigma 0 is not present, right? So cut sigma. Now see if 0 is present anywhere. So no, 0 is not present anywhere, so it will stay in the same state. So Q0. Okay. Now sigma 1. So see if there is sigma anywhere here. so there is no sigma, right? Sigma 1, right? So strike it off. So 1, so 1 is present in the next state q1, so q1. Okay, now take 1 0, see if there is 1 0. Yes, 1 0 is in q2. Okay, now take 1 1, 1 1 is not there, so strike off 1, and there is remaining is 1, so 1 is in q1, so it will remain in the same state q1. Okay, now take 1 0 0, so 1 0 0 is in q3. Okay, and 1 0 1, so 1 0 1 is not there, so strike off 1, and 0 1 is also not there, so strike off 0 and 1, so 1 is there in q1. Okay, now 1 0 0 0. Okay, now it's not there, so strike off 1, and 000 is not also not there, so strike off 0, and 0 0 also it's not there, 0, so 0, so 0 is also not there, so it will go to the initial state, so it will go to q0. Now take 1 0 0 1. Okay, so it's not there, so strike off 1, 0 0 1 is also not there, strike off 0, 0 1 is also not here, so strike 0, so 1 is there in q1. Okay, now we have successfully constructed the transition table. So with this, now we can easily construct the transition diagram. Okay, and now let us construct the transition diagram. So it's very simple to construct the transition diagram after constructing the transition table. Okay, so the states are q0, q1, q2 and q3. Okay, now q0 on 0 goes to q0 on 0, and q0 on 1 goes to q1. Q0 on 0 goes to q0, and q0 on 1 goes to q1, and q1 on 0 goes to q2. q1 on 1 goes to q1. q2 on 0 goes to q3. q2 on 1 goes to q1. q3 on 0 goes to q0. And q3 on 1 goes to q1. Okay, now we have the transition diagram. So now let us check this with an example. Okay, so example, one 0 0 1 0 0. Okay, so q0 is the initial state, so q0 on 1 goes to q1, and q1 on 0 goes to q2, and q2 on 0 goes to q3, and q3 on 1 goes to q1, and q1 on 0 again comes to q2, and q2 on 0 again comes to q3. Okay, so we don't denote the final state like this. So our logic is correct, and we have successfully constructed the DFA. Thank you for watching this video, and please do subscribe and share the video.